This is the solution to the 2011 question 12b physics higher level question. State the laws of refraction of light. So the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. The other one is that is number one, that is number two. The other one is that sine I over sine or is equal to a constant, where I equals the angle of incidence. This is Snell's law. You can write it out if you want. And or is the angle of refraction. I just think it's a little bit easier when it's the formula. A lamp is located centrally at the bottom of a large swimming pool 1.8 meters deep. Draw a ray diagram to show where the lamp appears to be as seen by an observer standing at the edge of the pool. Okay, so let's give ourselves a little bit of space. So there is the observer, and there's the water. Okay, so there is a lamp, and the idea is that, okay, so I wanted to do this. And then when you're going from a dense to a rare, it bends away from the object, or away from the normal. Okay, so the person thinks that the lamp is here. So this is the apparent position. So you bring it straight back from where they think they're looking. Okay. At night, when the lamp is switched on, a disk of light is seen at the surface of the swimming pool. Okay, so this is Snell's window. Explain why the area of the water surrounding the disk of light appears dark. Any light striking the surface at an angle greater than the critical angle is totally internally reflected. I should have probably just said undergoes total internal reflection. So this is the idea that if it's over here, it passes some critical angle and then bounces back down, or anything beyond this point. Okay, cool. Calculate the area of illumination of the disk of water. Okay, so again, following this, imagine this is my critical angle here, okay? And remember, it's with the normal, not with the surface of the water. This is going to make a cone of light, right? So there's going to be a circle up the top, and I need to calculate this radius here. So I need to calculate this distance. I know this is 1.8 meters. The question told me that. The question also told me that the refractive index is 1.33. Sorry, you couldn't see the radius there. There's my radius I'm looking to calculate. This is 1.8 meters deep. So I need to solve this. This is 1.8. The refractive index of the water is 1.33. The question, n, that was n. Refractive index is 1.33, and the critical angle C is 1 over sine of n. So it is 1 over, no, other way around, I'm an idiot. The refractive index is 1 over sine of C. I want to know C, so I've got sine of C is equal to 1 over n, and therefore C is equal to sine inverse of 1 over n. Sine inverse of everything. Yeah, this is something people, a mistake I've seen a lot is where you do 1 over the sine inverse. So it's sine inverse of 1 over n. So second function sine, put my bracket, 1 over 1.33, close my bracket. So the critical angle is 48.75 degrees. Okay, so now I know this angle. Because that's a straight line that's parallel to that, that means that this is actually my critical angle here as well. Okay, there's my critical angle at the bottom. So it's tan, isn't it? Tan opposite adjacent. So I know that the tan of the critical angle is the OR divided by 1.8, the opposite divided by the adjacent. So that means 1.8 times the tan of the critical angle, which I know is 48.75 degrees, is going to give me my radius. Once you know my radius, I can do what I'm looking for, the area, isn't it? 2 pi r. Sorry, pi r squared. Okay, so the radius is 1.8 times tan of that angle. So my radius is 2.05 meters, and then the area is going to be pi times that radius squared. So I'll square my answer and multiply it by pi, and I get an answer of 13.238 meters squared. Yeah, so it's pi times 2.05 squared, just in case you're wondering where I'm getting that from. Okay, so just to go through it again, any light that's greater than the critical angle bounces back. So there's going to be this cone of light coming up from that you can see. So from the surface, it just looks like a circle of light. So the cutoff point is this critical angle. To know this critical angle, I have to use this formula down here for the refractive index. The refractive index is 1 over sine of c. Multiplying both sides by sine of c and dividing both sides by the refractive index n, I can rearrange the formula to give me this. Then I take sine inverse of both sides. So c is equal to the sine inverse of the entire right-hand side. So sine inverse of 1 over n. So should have written that in. Sine inverse of 1 over 1.33. Okay, that gives me 48.75 degrees. Back over here, if that is C, then this is also C because of alternate angles, is it? I think they're called, or corresponding angles. I can't remember my maths exactly right now, but that's a straight line. That's parallel to that, so those two angles make sense. And then I can use tan to find out tan is opposite divided by adjacent, so OR divided by 1.8, and yeah, so let's keep going. Tan is OR divided by 1.8, rearrange it to get OR, 2.05, and my area of my circle is pi times that OR squared, which gives me 13 and a bit square meters.